Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge. Another question. So yeah, let's get started with it. But yeah, before we begin, one thing I just want to clarify, and that is like even if AI comes into picture, which is already coming into picture, but still solving Leetcode, doing code forces, doing code chef, all these things. It's not about if AI can solve it, then we shouldn't solve it. Anyhow, it is solving. It's all about building your problem solving skills. And when we do DSA and all these stuffs, it actually builds our problem solving skill. So we are doing for ourselves, not for the fact that AI will take up job, AI can do it or not do it or something like that. So it's always better you stay positive, think in a good manner, and always upskill most probably in upcoming videos also, not about in these daily challenges but in other videos also. I'll make a complete series that how to leverage AI in your day-to-day work and all those things. But yeah, today's focus is about Leetcode daily channel, and let's get started. So today's question is XOR after range multiplication query I. So this is a medium level question. So let's first check the constraints which are there, then we'll go ahead with anything else. So the constraint says that n, that is nums.length, means a nums array is given to us. That's length is up to 10 raised to power 3. The nums of I can go up to 10 raised to power 9. Then we have q queries, and those q queries are up to 10 raised to power 3. So even if we go ahead with n square solution, it will go up to 10 raised to power 6. So that is like almost we can say it will be good enough. Then queries of I consist of only these four variables, none other than that. Then our left and R which are there. Minimum they are 0 and maximum they can go up to n. So again we don't need to have any edge case for handling that also. Then our k which is there that always starts from 1 and it can go max till n. Then v which is there that it is at minimum 1 and at max it can go to 10 to the power 5. Now, like what these variables are, let's read the question. So we will get to know what these variables are. But just wanted to know that how the constraints are and how we can go with the question. Now here, let us read this question. So you are given an integer array nums of length n and a 2D integer array queries of size q, where queries of I equals to li, ri, ki, and vi. So for each query, you must apply the following operation in order. So set idx equals to li. So whatever index you will be taking, that should be set to li. And then while our idx less than equals to ri, while this condition is true, at that point only we need to update nums at that index equals to nums of index multiply by v of I. So here we check constraint that v of I is up to 10 to the power 5. So the multiplication can give a really bigger number than integers. That is what that constraint tells us. So the question was nums of index means integer at that particular index we need to multiply by v of I. Then we need to do modulo with 10 raised to the power 9 plus 7. Basically just we need to do modulo after doing the multiplication. So that this thing which is there, because if you see um, this nums which is there here also, whatever is there, it is all in integer format and we need to maintain that limit. So maybe that's why they have just given this modulo thing also. Then after this operation is done, then we need to set index plus equals to k of I. Basically we need to add into that index up to k, not up to k, basically we need to add the k, whatever k value is given to us, that we need to add into that index. And here we check the constraint for k was that it can go only up to n, not even up to 10 is to power 5. But still anyhow we will be having this condition that while index is less than equals to ri, then only this operation need to be done. So anyhow even if that ki was more than n, still it was like fine, because anyhow we have this condition that index is we need to perform these operation only and only if index is less than equals to ri. Like what I exactly want to say here is, so White is black. We want it white on blackboard. Okay. So basically, our index which is there, that is always less than equals to r. So this will be our while condition. So now this index need to be incremented as index plus k. So even if k becomes like 10 raised to power 5 also, so now the new index that will be equals to whatever previous, say it was 1, so it will be 10 raised to power 5 plus 1, something like that. But we have condition that this thing which is there, it will, we can only go with these lines until unless this is basically less than r, right? So because of that thing only, here the thing is that this index, as it is always less than r, so because of this thing, it can, like, we don't have like even concern about what is the value of k. It will be always holding in the limits because of this condition. So that's the thing. Now let us go back to our question. So our question next says that we need to set this, that is done, fine. Then at the end, means after doing those operations, what next need to be done? So that is return the bitwise XOR which is there of all the elements in num after processing all the queries. So basically because of this, whatever existing element was there, means because of this operation which we are doing, whatever existing elements were there, those will be now changed to something new. So after that, means after we got all the new elements, means this queries 2D array which is there, that gets exhausted. After that, we need to actually perform bitwise OR of all the elements which are present in this nums. So that is the last thing which we need to do. So like, even if we go ahead with any optimization or something, let us go ahead and code this the way they have mentioned. And what they have mentioned is, like, they have mentioned that first thing we need to extract from this, means first thing we will be extracting, and after extracting we need to just perform first thing, just assign this, and then we need to have this limit, perform this thing, and then we need to just increment it. These operation we need to do, and after this particular whole for loop which is there of the queries which will be there, that is done, then we need to perform this bitwise OR of all the elements. That is the thing. Now let us just go ahead and like code it, or better I can give you steps like extract from that queries which is there. First is this step, what we need to extract, basically all these variables which are there. Then second thing what we need to do is we need to perform, means first thing anyhow it will be, we need to assign index with L which is there, and we will be having that R also with us from these queries. So third thing, we need to have a while loop, and that while loop will be something like index less than equals to R. That thing is there, and because of that while loop only, everything will be in limits, means this index thing which is there. And then first operation we need to do, that first operation we need to do, and then second operation which we have, that index plus equals to our key value which is there. And once this is done, then fourth thing which we need to do is like, anyhow this whole thing which is there, that will be in this loop, in loop of queries which is there, it will be there. And the fourth thing which is there, we need to just do bitwise OR. And we know how we do bitwise OR, like we will be having some answer equals to 0, and then answer XOR equals to whatever element we will be having from that nums. So that is how that bitwise OR will be done. So after this, just pause the video and just try to solve it by yourself and check if that works or not. And once you are done, then you are good to go. If not, then fine. Anyhow, next I'm going to code it. 1 minute. Okay, now let us just code this. So the first thing which is there is we need to extract, right? So for extracting it, first thing we'll do is we'll just have sizes of each and everything which is there. Nums dot size, let's have that. Then let's have query size, queries dot size. Fine. These two things are done. Now we need to get from the queries which is there. Yep. And we need to go ahead int I equals to 0, I less than what is the size of queries that, because we need to have all the queries which are there, I plus plus. And in this, every time what we will be doing is for extracting from that queries, because there are 4 parameters in a single row, right? So for that purpose, what we'll do, let us say we have some vec which is representing an individual vector. Then for that, and I have taken it as auto, anyhow it is like vector of int only, just taken it as auto. Auto vec equals to queries of I. So this will give me first row itself. Now I need to extract each and every element. So int first element is L. So L equals to, we have that vec, L equals to vec of 0. Then we have R, that is vec of 1. Then we have, what is next one? K, and that K is vec of 2. Then we have V, that is vec of 3. So by this, we are basically able to extract each and every element from that single row. And anyhow, as it is in the loop, so whenever like I becomes 0, then I becomes 1. So every time new things will be extracted. Now after extracting them, we need to go ahead with the while loop. That while loop says that it should be something like this, right? And before that, we want one index also, right? Which we will be assigning with L. So this was just for ease, we did like this, or better we could have like directly taken index equals to this, because anyhow we are required to assign it, right? So while our index, that is less than equals to R, till then we need to perform all the operations which are there. So our first operation is that nums of index should be equals to, they have mentioned, let us just copy paste it. I know not exactly it will work, because other things which are there is we actually require const mod equals to, that was 10e, because it is about the 10 raised to power 9. So because of that only we have that 10e thing which is there. So that const, anyhow we won't be changing it, const in 1e, that is raised to power 9 plus 7. Okay, this is like directly we can use it, and also we just took from there. So because of that thing, anyhow it won't take the operators correctly, so it's better. And vi also, it's not vi. Yeah. And yeah, so this is the thing which is done. Now next thing is we need to actually increment by k, right? So that thing we'll do. So till this point everything is done, everything looks good. Now with the for loop, every element will get changed and all that, so it will just carry on like that. Now the next task which is there, that is about bitwise operation which is there. And one more thing, here this v multiplication which is there, if you checked this v which is there, that can go up to 10 raised to power 5, right? So because of that, we need to add one thing, one ll multiply by nums, so that it doesn't throw runtime error. Basically multiplication of the long with long is required, and that's why we need to, where is my cursor, we need to add this one and l multiply with this, and then we need to multiply by v, this is there. Now this thing is done. Now first answer equals to 0. Now we'll go ahead with the whatever, anyhow it was assigning to the original nums itself, so that's why we'll go ahead with whatever numbers which were there in that. Anyhow we commonly use, but let us take numbers, number in nums. And then at the end I just need to return answer. So this was whatever it was there. We did like that. Let us run it. Yeah, it passes these test cases. Let us submit it. Yeah, it works fine. Now let us first analyze like why it worked, what is the time complexity, what is space complexity. So if we see here, we have this loop which is of like order of q, which is there. We'll analyze what q can go so up till what by checking the constraints. Now this is fine. Now this is another loop which we are having, and that loop which is there that goes up till n, um, up till r which is there. So it goes up till order of r. Now this thing which is there, this is anyhow, we can clearly see it can go up to order of n. Now let's analyze. So this is order of q. So how up till what q can go? So here if we see q can go up to 10 raised to power 3. So this is 10 raised to power 3. Then we have r. Now r can go up till what limit? That is also till n it can go. So it can go. So basically rather than order of r, we can have it as order of n. And this is anyhow order of n, and n can go up to 10 raised to power 3. So n can go up to 10 raised to power 3. So this becomes like 10 raised to power 3, and this is also 10 raised to power 3 only. So the overall time complexity it goes up till 10 raised to power 6, like like almost permissible, not exactly but almost permissible. But maybe the constraints are like that it doesn't gives us TLE. That's why, but overall time complexity of this particular question is n square, which is there, which you can say, yeah, it is not that good as per the constraints which are there. But yeah, the way today it's about XOR after range multiplication 1. So most probably Leetcode will give us XOR after range multiplication queries 2 tomorrow, where we actually need to do the optimized version. So like let us solve that second question tomorrow with a more optimized version. But for this, now we know that the time complexity which is there, that is order of n square, and the space complexity which is there, if you see, we have not used any extra space apart from this thing, which is just storing four variables, which is almost constant. So that's why we have constant space complexity. So this was all for today's question. I'll meet you tomorrow with the next question of the Leetcode which is there. So this was all. Thank you.